All right, let's muscle through this here. So these are a bunch of just integration rules. I mean, pretty much the idea is if you integrate things added together, you can break them up into their own integrals. So the integral of a sum or a difference is the sum or difference of the integral. If you have a constant, we can bust that constant out front. And then this idea that if there's this value in between a and b, you can break up your curve. I guess it doesn't even have to be in between. It can go because you'd work backwards, but you can break up any sort of a function. So these are kind of fun. So I want to find the integral from 8 to 10 of 3 f of x plus 2. So I'm going to start off by trying to integrate some things. Try to integrate some things. I'm going to start off by trying to break this stuff up. So the best way that I've explained this, I think it's easiest to kind of look at it as a little chart. Well, let's write what this means first. So this would be the same as the integral from 8 to 10. Now I can take that 3, I can bring it out front of f of x dx plus the integral from 8 to 10 of 2 dx. So I think it's kind of the easiest way to kind of figure this out is to make a little chart. So over here, I'm going to draw I'm going to make a number line based on what info they gave me. So the whole interval, the lowest number is 0, the biggest number is 10. Along the way, the other numbers that we care about is 8. And now I can start to plug in values based off of these integrals. I know there's some curve up here and we're actually doing areas and all that stuff, but in my head I thought it was just kind of slick to say, all right, from 0 to 10, this distance is 17. Really, it's an area under the curve, but in my head it made more sense to write it as a distance. Then from 0 to 8, so from here to here, is 12. And then from 8 to, so now what we need to do then is we need to figure out, using these clues, all the information that we can, because we really want to know what's happening from 8 to 10. Well, they didn't tell us what's happening from 8 to 10, but because of these other facts, we can figure out. This is kind of like those puzzles you did in middle school where they give you they give you an irregular shape and they give you some information and you work around. Anyway, so if this was 12 and the whole thing was 17, well, then this must be a gap of 5. Now I can start to evaluate this up here. 3 times what's the integral from 8 to, that's 5. Plus, what's the integral of 2? Now these are kind of easy. These I kind of went over it fairly quickly, but the integral of a constant, basically what you're doing is you're taking the constant out and then you're integrating 1, which would just be x, all right? So it's just going to be that height. So I didn't explain that very well. 2 times b minus a, 10 minus 8. I mean, think about why that would be. So let's try to turn this, I can explain that better. Let's try to take this and turn it into a picture. So I'm trying to figure out my curve. My function is just the function 2. So that means my graph is going to be at a height of 2. I want to calculate the area between 0 and 10. So that means I want to find, between 0 and 10, between 8 and 10. Between 8 and 10. That means I want to figure out this area right there. Now that's easy. That's a rectangle, right? Now what's interesting, this is why this is such a nice shortcut. How tall is that rectangle? It's going to be whatever this function is. All those function values are the same. How wide is it is going to be whatever the gap is in between those two. So this is a distance of 2. That's a height of 2. So that's how I calculated my area. That's 15. That's 2. 2 times 4. So I ended up with 19. Okay, so I'm going to encourage you to pause and try to do 2 things. I would encourage you to try to rewrite this as best you can, splitting it up, and then try to draw a little graph, a number line of what's happening. All right, let's see how you did. I'm going to rewrite it first. So this is going to end up being, so I'm going to split these up, and I'm going to take this constant of 1/2 out of the front term. So that's the integral from negative 6 to 3 of f of x dx minus the integral from negative 6 to 3 of 3 dx. Now, did they just tell us? Nope, they didn't tell us any of that. They didn't tell us any of negative 3 to 6. So we have to infer that. We have to figure that out using our areas. Now, I'm going to just pretend like it's a number line instead of the areas. So what numbers are we? What's our lowest? Our lowest is negative 6. What's the highest is 7. And then it looks like we hit 3 and 4 in between. Now, I know I should probably write this neater than I am, but I don't really care how spaced out they are. I'm just going to use this to indicate the areas over those regions. So let's, math voice right off the bat. From negative 6 to, this is backwards. It's going from 4 to negative 6. I want to flip that around. So from negative 6 to 4, it should be 3. From 4 to negative 6, it was negative 3. I want it to be going the other direction, so that's 3. So from 3 to 7, that's going in the right order, so that's a gap of 9. Well, I already can figure something out, I can tell, but I'll wait and just put down everything they gave us. And then from 4 to 7, is 5. Wait a minute. I was throwing myself. That's okay. So I thought these two should add up to that, but we've got this gap over here. So now, how far apart is it from negative 3 to 6, which is the region that we actually want to find? And from here to here, well, let's think about it. So from negative 6 to 7, according to these two, that has to be a distance of 8. Well, this gap and the orange gap have to also add up to that same number. So what's this left? This must be worth negative 1. That area must be accumulated under the curve. So now we can start to plug and chug here. 1/2. Negative 6 to 3, it's in the right order, of f of x would be negative 1. Minus, and here we go again, this is a constant, so it's at a height of 3, and then you subtract how far apart these things are. So from 3 to negative 6, that's a gap of 9. So that's negative 1/2 minus 27, which is negative 27.5. What do you think? The next ones are fun. The next ones are fun as well, in my opinion. It's just sort of that you just kind of figure it out. These are just kind of like puzzles. They don't feel like calculus to me. So we know they're telling us. This is our graph of our sine curve. Hopefully you notice that. They're telling us. They know that we know from 0 to pi, this is an area of 2. And then we're going to try to figure out a bunch of other stuff that's not given to us in the story. All right, so what's the integral then from pi to 2 pi? Well, that would be the continuation of this graph, right? Where would this is pi, this is 2 pi, where would the next part of that graph be? That would all be down here. Now, it's going to have exactly the same area, but where is that area located? Below the x-axis, so this would be negative 2. All right, now we're going from 0 to 2 pi, so you start here, you take all of this accumulated area, all of this accumulated area, and add them together. Well, this is positive 2, this was negative 2, so this area has to be 0. You get in the game? All right, I'm going to encourage you to pause and at least try to do one of these at a time, and I'll do one, and then you can pause again and go on from there. Okay, so from pi to pi over 2, so pi is here, right? This is pi. Pi over 2 is back here. Oh, that's backwards, okay? So the area, this whole area is 2, so from here to here is half of that, but we're going in the wrong direction. So that has to be negative 1. From 0 to pi, so that's okay, this is my region, of 2 plus sine of x, all right? So I'm going to break this up. This is going to be the integral from 0 to pi of 2 dx plus the integral from 0 to pi of sine of x dx. Constant, so that's the height, my function, multiplied by b minus a, so pi minus 0 is pi, plus the integral, oh, well, that's what they gave us, so we know that's 2. So this ends up being 2 pi plus 2. All right, from 0 to, oh, that's just a constant, man. Constants are a breeze. I'm going to bump it out first. We already know that that was given to us as 2, so 2 times 2, this ends up being 4. Wish I would have changed my colors. I don't know why I stayed with the same colors. Sine of x minus 2. Oh, interesting. So what does you can't distribute this sign and then break it apart. But think about it this way. So this x minus 2 does what to my graph? It shifts it, right? That's a x shift. So that's going to shift my graph forward 2 spots. So my original function was, remember, they gave us from 0 to pi of sine of x. Well, what did they do? They just added 2 to everything. So it's going to be the same. This area was 2. Well, if I take that graph and I shift it down 2 spots, or sorry, shift it horizontally forward 2, it's still going to be the same area. It's just going to be moved down the line a little bit. All right, 0 to 2 pi. So now we're going all the way there, but we're putting a 1/2. Now remember what that means. So if I go from 0 to 2 pi, this means that my heights, hold on, let me think. All right, I got it. I remember now. So sine of x over 2. So this is going to be I'll mix up my colors finally. Remember, anything next to x in a function does the inverse of what it says. So this says x minus 2. So that took the x values and added them to it, shifted them forward 2. So this took x and divided it in half, or sorry, divided it in 2. So what that really does to your function is it takes it and it stretches it out. So it does a horizontal stretch. So my original curve from 0 to 2 pi for sine would look like that. Well, when I take this and I multiply it by, I'm going to change that to brown. When I divide x by 2, that actually takes my graph and it stretches it out like that. So now what's my from 0 to 2 pi? That's going to be the exact same area as the area that I had here. I just took that area and I stretched it out farther. So that's still going to be worth 2. And then so I want to go from negative pi. So remember, here's pi, so here's negative pi. So from negative pi to pi, well, this is below the x-axis. Oh, dang it. That's not pi. This is negative pi. So this is below the x-axis, that's above. That's going to end up being 0. 0 to pi of cosine. Uh-oh, we better sketch cosine here. Cosine starts high and goes low. So this is 2 pi. This is pi. This is 0. All right, so from 0 to, yeah, look, it's going to be a little bit above and a little bit below. So you're going to have your same amount above and the same amount below. So that's going to end up being 0. Oh, dang it, I didn't do a good job again. All right, from 0 to 2 pi of cosine, yeah, it's the same thing. Look, above, below, below, above, we're going to have the same boat. It's still going to be worth 0. All right, give that homework a try. So I went back. Sorry, I told you to go to the homework. I went and looked. This one felt fishy to me, so I looked it up. I did. This is not correct. This should be 4. Let's talk about why. So I want to integrate. So let's sketch the curve first. So here's 2 pi. Here's pi. So the original sine curve is going to go up to a height of 1, like that. Now I was correct that this thing is going to stretch out, but it's going to stretch that area along the whole thing. So this is going to be clearly more than what it was before. So that area from there to there. So this area, basically this hump got stretched into twice as long of a hump. So it's going to be the same height, but the base is twice as long. So that's going to actually make that area go out to become a 4. So, all right, now get that homework done.